Now, how do we classify matter based on its composition? So let's start from the very basic. So for the matter, we know that, okay, it occupies space and it has mass. So now let's just put it at the very beginning level. Well, let's think about pure substances and mixture. All right, so pure substance, mixture. How do we define pure substance? Well, if it contains only one type of substance. All right, so you can look at my PowerPoint slide at the moment. You can see there all the little symbols that you see on the lower left corner. They're all just one type of substance. All right, meaning it's either they're all red or green or just blue and pink together. It's just one type. Okay, one unit, one type. All right, there's no mixture. For the mixture, that means you can have more than one type of substances. All right, so that's something that, what does that really mean, right? So mixture, how can we think about that? Well, the easiest one, in my opinion, will be you can have sand and water, you mix together. You can totally see two different substances mixed together. Or when you're looking at your vinaigrette, so you see the oil and the water mixed together. Well, I mean that they're together, but you cannot really mix them well. But we'll classify it later. What does that mean, right? But there's also another different kind of mixture. For example, it would be like air, right? So as you may know, in air, we have nitrogen gas, we have oxygen gas, we have carbon dioxide gas, we have other noble gases as well, right? You cannot see, but it is a mixture, all right? So I think that gives you a little perspective on mixture. Sometimes you can see, sometimes you cannot see, all right? They're still mixture because they're composed of more than one type of substances. Okay, so keep that in mind. You do need to know the definition, because if you don't know the definition, you cannot classify the substance. Okay, so in chemistry, you need to know the definition. Once you know the definition, then now you know how to apply the definition. Again, our job is to be able to apply the definition. Just the fact that you know the definition, this is not really good enough, because that's like the level one kind of question, like what's the definition? But remember, in terms of STEM education, we need to be able to apply the definition, not just knowing the definition. So let's take a look at pure substance. As I mentioned before, pure substance means a single kind of matter. Single kind of matter. So you can see in the slide, I have 3 different circles, and then inside each circle, you can only see one kind of matter. You don't see different type. For example, look at the first circle, all you see is a single green atom just bounce around. You don't see different color. You don't see 2 green atoms comes together as a unit. It's just a single sphere representing an atom. Then you look at the images in the middle. This time you see the same pure substance get together as a unit, and then they move around. You only see 2 blue atoms coming together, forming as a unit, moving around. Then the third picture is still a pure substance. Actually, this is actually water. All right, you have the you have the red atom in the middle. That's signifying the oxygen, and then the 2 hydrogen represented the white in color. So again, all you see just water molecule bouncing around. You don't see any other type of substance. So when you have this microscopic picture of a pure substance, that's what we try to make a connection between macroscopic level to the microscopic level. All right. Later on, we're going to write chemical reaction. So we're going to study at 3 different levels: macroscopic, microscopic, and the abstract written chemical reaction style. So then now mixture. As I mentioned before, mixture is 2 or more pure substance mixed. And when I say mixed together, they are not really chemically joined together. All right, so when we say chemically joined together, that means they form a chemical bond. They stay together, okay, as a fundamental unit. So for example, you're looking at the image right now, you see I have some green atom bouncing around, and occasionally you see the water molecule, and also two of the blue atoms stick together as a molecule, mixing in a little circle together. Again, they are free to move around. They're not chemically bond attached to it. So this is what we call a mixture, when you can see more than one type of pure substance. So now we just summarize what we talk about. We talk about what matter is. We talk about what pure substance is. And then we talk about mixture. Now let's go into a little bit deeper in terms of the pure substance. There are actually two types of pure substance: elements and compound. What does that mean, right? An element is made of only one type of atom. As you can see in the image, you can see just all the red particles, and then the other one just all the green particles together. There's only one type of element. So that will be considered an element. The other part of the pure substance, a compound, now it will come from more than one type of element. Okay, so one type of atom. So for example, you see the images, you can see the blue and the pink atoms coming together. They form a chemical bond. They are touching each other as a single unit. That will be considered a compound because it's more than one type of atom joining together. Or you can also see the purple and gold, right? The licorice color. Again, that is also considered a compound because it's not the same element throughout when you're looking at the substance. How do we deal with that microscopically? So again, visualizing the process. Okay, I have a pure substance, and then now from the pure substance, do I have elements or compound? Look at the little particles, right? See, can you find more than one type, right? Are they joined together differently, right? So in this case, well, on the circle on the left, all I see just green atom bouncing around. Okay, that's no other thing else. Okay, nothing. The other one, just the blue particles together. So that those two, what I'm seeing right now, that will be considered elements. So just one type of atom. For the compound, when you have more than one type of atoms, for example, H2O, many of you talk about it in your self-introduction. So that is a compound. And another compound that you may have used in our daily life will be table salt. So what I have is an image of a table salt, NaCl, sodium chloride. That is a table salt. Pretty much will wrap up what we have in the pure substance for the moment. So now let's jump back to the mixture. Okay, for mixture, we have two types of mixture. Earlier we talked about air, something we cannot see, but it's a mixture. And then we also talk about oil and water, the vinaigrette mixing, something that we know is a mixture, but we can see different layers, right? So that means in terms of the definition, we have two types of definition for mixture. We have homogeneous mixture and we have heterogeneous mixture. So to continue with our discussion on mixture, again, here are two examples. The first example, I'm putting sugar into water and then I mix it, and my sugar would dissolve in water, and I will not be able to distinguish where's the sugar, where's the water. Everything is just a uniform texture. So this will be an example of homogeneous mixture. Another example, as I mentioned before, I add sand into a beaker of water, stir. After I stir, it becomes a mixture. Again, I can see the sand, which will be at the bottom of the beaker, and the water. It's two different phases. Okay, so that will be an example of heterogeneous mixture. Take the whole overview again, right? What have we gone through so far? We talked about matter, which has mass and occupies volume. Then we split that into pure substance and mixture. For mixture, we have homogeneous mixture, heterogeneous mixture. Then for the pure substance, we have elements and compound. Now then we need to go a step a little smaller. Then it's like, okay, now if we talk about elements, right? How can we classify elements? Basically, two kinds: atom, atomic, or molecules. Okay, and then when we talk about compound, also there are two types: molecule or ionic compound. So we're gonna dive into each one. So first, let's talk about atoms. Okay, atom is the smallest units of any substance. So if you have just one type of atom, that will be considered atomic element. Okay, so in this animated pictures, all you see just green particles or green atom bouncing around. Okay, so it's only one type, and they're all individually by itself. So it's atomic elements. Then for the elements, we can also have molecule. Okay, and if you listen carefully about 2 slides ago, you say, wait, I heard molecule for both elements and compound. How do I know which one is which? How can I tell the difference? This is the part that visualization is really helpful. If it's an element, you will see only one type of atom coming together. Okay, so in the picture, you see the two blue atoms coming together, chemically joined together. That is a molecular element. Okay, so we're going to have some example later we'll look into, but this is considered molecular element. Okay, again, element only have one type of atom. What about molecular compound? What would that be? Well, there will be more than one type of atom chemically bond together. So for example, water, H2O, you have one oxygen and two hydrogen chemically bond together. Okay, so they are considered non-metal, chemically bond together. That will be molecular compound. So now what about ionic compound? Ionic compound is very different in the sense that it comes from the positively charged metal ions and also negatively charged non-metal ions. They come together forming a repeated unit throughout the structure. Okay, so in the sample I'm showing you, this is actually example of table salt, sodium chloride, NaCl. Sodium is a metal, so when it forms the table salt NaCl, it becomes Na+. So later on we'll describe physical properties, chemical properties, then you will see that then what they started with and what they end up with, they're totally different. Okay, so for now, what you want to remember for ionic compound is that you will have metal, non-metal ions coming together. Okay, they're in a repeated unit. Okay, throughout the structure. Then we have another type of ionic compound into a little more detail. Sometimes the water molecules from our atmosphere, they will form a chemical bond with the ionic compound. So again, this is actually part of the compound. They're chemically linked. Okay, so we'll study more in that in general chemistry too. So for right now, for example, copper sulfate. And you see that after we write down copper sulfate, you see a little dot and then with 6H2O. What it's telling you is that the ionic compound that we're looking at, the copper sulfate, it has 6 water molecules chemically bond to it. Okay, so it's actually as a whole single unit. Do we still consider ionic compound? Yes, we still consider that as an ionic compound. And also, yes, we also consider that as a pure substance. So here's the summary of what we have talked about. Okay, so once we know how to classify matter, and then now we need to talk about the basic unit, right? So for atomic element, the smallest unit will be the atom. If we're talking about molecular elements, then the smallest unit, it will be molecule. If we talk about molecular compound, once again, the basic unit, it will be a molecule. Okay, so molecule will be the most fundamental units. Like, yeah, 1 molecule, 2 molecule, 3 molecule. That's what we mean by the basic unit. And when we talk about ionic compound, now this one you have to pay attention because it's different terminology. For ionic compound, we use something called the formula unit. Okay, what is the smallest whole number ratio? Okay, remember it's whole number. It's not 1.5, 2.7, or 0.2. It has to be the whole number. For example, NaCl, 1:1. Calcium chloride, it'll be 1 calcium, 2 chloride. This is a summary slide of what we talk about, how we define elements, how do we define molecules, compound, and a mixture solution, and then the basic units describing that pure substance.